Hello, everyone. My name is Shen. I'm from Texas A&M, and today I'm going to talk shortly about the ionization properties we study from using NGDEEP survey. So before I jump into the science, I want to introduce you the NGDEEP survey. This is a two-component, it includes two components. One is the nearest part, and it focuses on it's pointing on the Hubble ultra deep field, and the goal for that is to study the emission line diagnosed for galaxy at redshift 2 to at redshift 0.5 to 4 for low mass galaxy, like 10 to the 7 to 10 to the 9. And the NIRCam part, we're doing very deep NIRCam imaging, and the goal is to study discover and characterize high redshift galaxies. So here I'm showing in the middle is a stacked 2D spectrum for galaxy the 2D spectrum we took from nearest, and on the right plot is showing the H alpha maps we reconstructed from the nearest observation. And on the bottom is also showing the O2, O3 H alpha emission line maps that we're going to do with the resolved study for those line diagnostic for galaxy at redshift 2 to 3. For this small talk, I want to introduce we study the O3 versus O2 ratio for galaxy at redshift 2 to 3 as a star-forming galaxy, about 148 galaxies. And here is showing the stellar mass versus star formation rate plots. And we have a galaxy down to the 10 to the 7 solar mass, and the median is around 10 to the 8.4, 8.5 solar mass. And we're really going down to low mass galaxies. And because we are using emission line selection, so we find our galaxy has star formation rate higher than the main sequence. On the right, I'm showing the O3 versus O2 ratio as function of stellar mass, and the colored dots are the data we have, and we see very significant mass versus O3-2 ratio extend to very low mass galaxies. And we also see there's an offset, 0.5 offset, 0.5 DAX offset between the redshift 2 versus the local low redshift galaxies, and suggesting that either high ionization parameter or low metallicity are in the high redshift galaxies. And we also see the O3-2 ratio as function of star formation rate, and we see the difference, the offset is even larger when comparing to the low redshift galaxies. And we also compare the O3-2 ratio versus specific star formation rate and equivalent with H alpha here showing on the right plots. And we see there's a strong, significant relation between the O3-2 ratio and those specific star formation rate and equivalent with H alpha. But we don't see, when we compare them with low redshift galaxy, we don't see a very different, as similar, as fixed specific star formation rate or as fixed equivalent with H alpha. So this suggests a uniform connection between the fraction of young to old stars. Or we also see that in when we compare the UV, the H alpha versus UV flux. So this is recent burst, and the connection between that and between the power of ionizing photons. Thank you.
Thank you. Thank you, Lu. So I think that we can thank all the morning speakers again. And go for coffee. We reconvene at 11 o'clock.